So we've been talking about graphing things like this, right? And talking about what's the domain. X can't be -1 because we'd be dividing by 0. Or ideas like as x gets really big, as x approaches infinity, these two terms start to take over. So y would approach 3 because 3x over x, 3 over a million divided by a million is 3. 3 times a million minus 5 over a million minus 1, the minus 5 and the minus 1 are so tiny, they don't matter. Or make it a billion, and it gets closer and closer to 3. So we've had this extreme behavior talking about it. We've also talked about how sometimes we'll get holes, right? Like if I had this x minus 5 over x plus 5 times x minus 5, that divides out. So it's basically the same as this graph, but with a hole at positive 5. So x can't be positive 5. Now sometimes we'll have a shape like this where nothing's going to cancel out on us, but we have, since these are 1 power apart, s squared on top and x on the bottom, as x gets really big, this tends to x, it seems like. So it grows, it feels like it grows without bound, but x divided by x is x, so it makes a straight line. So we can actually, from here, have what's called a slant asymptote.
Oh, this isn't going to go into that evenly, so we have a slant asymptote. So let's go ahead and figure out how to find it. So this top, this x squared minus 25, think of that as x squared plus 0x minus 25, and that's being divided by that x plus 3. So let's go ahead and do that division. And I'll use synthetic division for this. So -3, right, grabbing the 0 from that, is going into 1, 0, -25. So bring down the 1, multiply by -3, add, multiply by -3, we get 9. -25 plus 9, what's that, -16? So notice that's our remainder. So we've got this. So what that means is this divided by this is equivalent to x minus 3 minus 16 that is still being divided by that x plus 3. And then if you look at this, let x go to 0. Let x go to infinity. Let x get really big. Because we're talking about extreme behavior with asymptotes. So as x gets really big, notice what happens here. 16 over really big is essentially 0. 16 over a million and 3, 16 over a billion and 3. So as x gets bigger and bigger, this gets closer and closer to 0, becomes insignificant. So this, y equals x minus 3, that's our slant asymptote. That is the thing that this gets closer and closer to as x grows without bound. Let's take a look on Desmos implications for that. So our equation is x squared minus 25. That's being divided by x plus 3. Whoops, I'll get that on here actually in a way that works. X squared minus 25. That's being divided by x plus 3. There's the actual shape. And notice what I said the slant asymptote was x minus 3. And that's this line right here. Let's make that dashed just so it looks like an asymptote. Like that. And so notice what happens is as we zoom out, the function gets closer and closer to it, but it never actually touches it. And what's interesting to me is this distance that's in here, that's the distance that's getting smaller and smaller, right? It's getting closer and closer to it. That's this value here. And just to emphasize, that value there is not part of the slant asymptote. This is the slant asymptote right here. So if it doesn't go into it evenly, and these degrees are off by 1, right? This is x squared, this is x. We have a slant asymptote. This thing never equal to this line, but it gets closer and closer to that line.
All the other stuff that we've been doing applies, right? Vertical asymptotes. It won't have both a slant and a horizontal asymptote. It'll only have one of the two. So on this one, I could try and factor that, see if something cancels out. It's not going to. So this is a good candidate for slant asymptote, right? X squared over x. So I'm actually going to do this division. Grab the 0, doing that synthetic division. 3x squared negative 2x plus 1. Bring it down, multiply, add, multiply, add, there's a remainder 2. So the slant asymptote is at x plus 1. And then I can do all the rest of my analysis that we were doing before as well. X squared over x. So let's do the division. 2 x squared minus, oh, I don't need the x squared. I'm doing synthetic division. 1x squared, negative 4x and 1. Bring it down, multiply, add, multiply, add. So my slant asymptote would be x minus 2. And again, that's not part of the shape. That helps frame the shape, right? So if I wanted to do some more analysis on this one, I know that it has a slant asymptote here. I know that x equals 2 would be my vertical asymptote. Well, let's sketch from here. I'm going to have an asymptote here. And then if I graph the line y equals x minus 2, slope of 1, but it goes through negative 2, so there's my slant asymptote right here. And it's either going to be in here and in here, or it's going to be, whoops, sorry about that, or it's going to be out here and out here. But it's going to be like framed inside those asymptotes. And then, like I said, all the other stuff that we've done, it all applies to this as well. We could find x-intercepts, y-intercepts if they exist, get some other points, and get them all in there. All right, that was a pretty quick lecture. One thing I do want to add to this about this slant asymptote, we could say as x approaches infinity, y approaches that, x minus 2. All right, give me some questions, post them in the forum, message me, do your assignments, let me know how it's going.